Okay, I feel like some people wanted some more examples, and so like the 10 or 15 minutes towards the end of class maybe wasn't enough, so here we go. I'm going to do 3 examples that get progressively more challenging. So you see the steps here that I pointed to at class, same steps, little asterisk. Sometimes you got to make the smallest coefficient bigger by multiplying. Alright? You're trying to make the coefficients the same. Okay, so that when you add or subtract, they eliminate. So right here, okay, that's unnecessary. So stuff lines up vertically, that's pretty much always the case. That rarely will try to be tricky or anything, but sometimes you might have to worry about that. B, make sure one variable is eliminated by adding or subtracting. So that's what this is saying. But here, if we added, the x's would cancel. Or eliminate, that's what they call it, elimination method. The x's would be eliminated. So that's what we'll do. We will add them. And we get 3x and negative 3x. Up, cancel. So we get 6y equals negative 18. And really, I can see why most students think this is a lot easier. Once you get all your ducks in a row, it's a super easy equation now relative to what you have to do in substitution method. Sometimes substitution method gets really messy. Here this is alright. We have 6y equals negative 18, so y has to equal negative 3. Okay? Then we go back to either one of the original equations. Doesn't matter. Oh, I don't know. I'll do the top one because it's all positive stuff. 3x plus 2 times negative 3. Negative 24. Okay, so this negative 3 is, of course, this negative 3. In case that wasn't obvious, it's 2y. So 2y is down here. So I just kind of truck through all this. That's an equals. I probably fix that, I should say. And then, so x is negative 6. So y is negative 3, x is negative 6. If you want to write it as an ordered pair, which is how the book always shows them, negative 6, comma, negative 3. So there you go. This is one where you don't have to worry about b, really. Here's one where you do. Make sure one variable will be eliminated by adding and subtracting. So if you add these, you get 6q, you get negative 8z. It doesn't help. If you subtract them, nothing cancels out, nothing eliminates. So you have to do something to make one of the smaller coefficients. Remember, so this is a coefficient of, I'll use the disappearing ink just for that because it's fun. This is a coefficient of 1. Okay? This is 6, 2, 5, whatever. Those are the coefficients. So you want to make one of the smaller ones bigger in order to kind of match up with corresponding coefficient in the other equation. So here, I would say that, I'll be irritated if I don't change. I'll forget. So back to regular pen. So doesn't matter. It's totally a judgment call. Whatever you feel like doing, I'm going to say, hey, let's make the 2 with this z same as, up to 6. So what I do, and here's how I usually show the work, I just write times, well, they go from 2 to 6, I better go times 3. Or negative 3. Now I've done examples, all made it work out the same way where you could add, so I'm going to do this example where you subtract. It does not matter really, but just check it out. So times 3, so we get 15q minus 6z equals 45. Okay? And I'm going to rewrite the second equation because my crummy handwriting made it so that nothing really matches up. So I'm going to just rewrite the bottom. So we have q minus 6z. And there we go. Okay, so if we add, it doesn't work. So that's why I subtract. Okay, I can subtract them. If you add them, I mean, the reason why it doesn't work, I just kind of said that as if it was an obvious fact. The reason why it doesn't work is that if you add these, you get negative 12z. So the whole idea is you want to get all the z's away. You want the coefficients to match up, either exactly the same or opposite, like right here, they're opposite. There's positive 3, negative 3. But they're opposites. In fact, I probably should put that in there. We add it. Okay? And they cancel. If they're the same, that's why we subtract. And that's not a very good looking minus symbol. That's the subtraction. So we subtract here. So we do 15 minus 1 is 14q. Negative 6 minus negative 6. So you do, I mean, if you need to go off the side and like verify that I'm not lying to you. Negative 6 minus negative 6 plus is 0. There's 0 z's. So now you can just say goodbye. And that equals 45 plus 11, because we're subtracting a negative, so that's 56. Okay? Divide both sides by 14, turns out that's actually 4. 56 divided by 14 is 4. So boom, there you go. Then just like the other one, I throw it back into either one of the original equations. I would say this, and probably doesn't matter. I'll do top, why not? Do the top one, 5q minus 2z equals 15. 5, I'm going to switch colors. 5q minus 2z equals the 15. So we get 20. So I minus 20, minus 20. You don't have to show that step if you don't like to. So we get negative 2z is negative 5. Z is negative 5 divided by negative 2 is 5 over 2. Negative divided by negative is an overall positive. So there you go. So Q equals 4. Z equals 5 over 2. 2.5. However you want to write it is okay. Okay, last but not least. What if you have to actually do something to both equations? Now technically that's never the case. You can always multiply something by a fraction to make it work, or a decimal to make it work out, but we all know no one wants to do that. So the trick for this one in step B is you actually have to multiply both by something. And that's fine. That happens. No big deal. And it doesn't really matter which one you use. This one definitely doesn't matter, whatever. Alright? But definitely nothing will cancel out. 5 and 3 don't match up. 4 and 5 don't match up. And you can't just multiply 3 by a nice whole number to get to 5. You can't. Same thing with 4 and 5. So what you do, and really this will always work. Okay? There might be simpler ways. There might be nicer numbers to work so that the numbers, you know, there might be tricks that are a little slicker. But what's up is pick either variable, G or K. It doesn't matter. I'll pick K. And what we do is we multiply. No, I'm not in pen mode. Back to blue. So I picked K. It doesn't really matter. I could have done G. And I say, all right, 4K and 5K. So I'm going to multiply this one by the opposite coefficient. And same down here. So I'm going to do 4 times the 5. So this is 5 because of this 5. And this, as you maybe guessed, it should be 4. Okay? And just like the last example, you distribute through both sides and whatever. So we have, the numbers are a little big, but we'll live. Oh, that's not the right thing. 25G plus and then the second one minus 20K. And if you think about it, that should always happen, that they then match up. If you multiply by the opposite number, you're guaranteeing you're always going to make a match up. That little trick always works. Okay, sometimes it gives you bigger numbers than you might want to work with, but it's alright, you guys will live. This is honors algebra 2, you guys are okay. Okay, so minus. And then here, since they are opposites, plus 20 and minus 20, we can really just add straight down. That's the eliminate the variable. So we add straight down. Oops, I had meant to have another example. And ignore, pretend that didn't happen. and we add straight down, and we get 25 plus negative 12, or 25 minus 12 is 13. What happened? So we have 13. Gee, this cancels, equals 78. Okay, divide both sides by 13, and I'm being so nice. Works out evenly. G equals 6. Alright, and then you go back, just like the other ones, you go back to one of the original problems, and you plug it in and figure out what it is. And I'll tell you what, I'll leave that to you guys. You guys do that, and maybe I will ask you to do that, or write down some other stuff tomorrow as your do now, as your please do now. I might ask you to do something like finish this problem, or maybe something else, I don't know. But there you go. Hopefully that is enough that you guys are pretty comfortable with elimination.